the plug-in or pick a number strategy for the Math ACT. This is one of 3 strategies, and this strategy can be used on a few of the 60 questions. And the first part of mastering this strategy is being able to recognize what type of questions you can use this on. Alright, so this is what I'm going to begin with in this video. The clues that you can use this strategy, and there are 2 main ones, alright. Right? There is a variable with an unknown value, and it would make sense to give this variable value. Variable a value. Or it might be helpful to give that variable a value. All right? Then the next clue is that answer choices are expressions, or they have variables in them, or it's a relationship of one variable to the other. So answer choices are expressions or contain variables. Otherwise, I like to say, in the question, if there's a whole bunch of variables and none of them have value and it doesn't make any sense, maybe it would make a little bit more sense if you assigned a value or a number to each one of the variables, all right? So that's what picking a number means, or plugging in a number, making up your own numbers. So those are the 2 clues. So if I was going to take the test and I arrived at this question, number 27, I read that Bob has $4 more than Lisa does. If Lisa has X amount of dollars, there's one of the clues that jumps out at me, okay? X amount, we don't know the amount. Maybe it would be helpful if we made up an amount for this problem. How much would Bob have if he doubled his money? If he has 4 more than Lisa and Lisa has X amount. So the first clue is that there is a variable that doesn't have a value, and maybe it would be helpful if we gave it a value, okay? The second clue is that all the answer choices are expressions, or they have that same variable in it. It doesn't make sense. How much money would Bob have if he doubled his money? That doesn't make sense that he would have X plus 8 money. That it just doesn't matter. So, or it doesn't make any sense. And so this type of problem and those 2 situations that occur clue me that I can use this pick a number strategy, okay? So the first step in this pick a number strategy is you do that. You pick a number for the variable or variables, depending on how many exist within the problem. Now, 3 things for the first step. Never pick the number 1. It just leads to multiple answer choices being correct sometimes. Then these other 2 things, you need to use some logic with them, because the numbers you pick must make sense within the problem, okay? So a lot of times if you're working with percentages, 100 would be a good number to pick if it made sense, because 100 is easy to use for percentages. And sometimes you'll hear problems that say X is a number that's divisible by 3. Well, then you would have to make X be a number that is indeed divisible by 3, so 9 or something. Okay? And then the final thing is something easy to work with. I always say use low numbers, so 2 through 5 if necessary, or if those make sense. Just make it a number that is easy to work with so you don't make the math harder than it needs to be, okay? So, with that being in mind, step 1 says to make up a value. I'm going to make up a value for my unknown variable. In this case, it's X dollars. I'm going to say that Lisa has $2. In this case, X doesn't need to be divided by anything. Really, all that's happening is 4 is being added to the amount that Lisa has, and so I can do 4 plus 2 pretty easily in my head, and 2 is a small number, so I pick that one. You can pick any other number. I promise if you do the eventual math right, you will get the same answer choice every time. But 2 is just a very low number. It's easy to work with, and it doesn't have to meet any other stipulations in this case, okay? So I'm going to say she has $2. So then step 2 states then, work the problem out with these numbers to arrive at an answer for the question. So using 2, I'm going to answer this question. How much money would Bob have if he doubled his money? Okay, so I'm going to work it back in there. Bob has $4 more than Lisa does. I said Lisa has $2. So if Lisa has 2, then Bob has 4. More than means plus. 4 plus 2 equals 6. So Bob, in this case, has $6. So then the final question to this problem, how much money would Bob have if he doubled it? All right, so he has 6. If I double 6, 6 times 2 is 12. So my answer that I arrived at for step 2 is 12. Now, if you picked a different value for x, you would get a different answer, but again, it should work out to be the same thing eventually. Step 2 is done. I worked the problem out and arrived at an answer. Step 3 says to use the numbers in the answer choices. So you use the same number that I made up. So in this case, I'm going to use x equals 2. I'm going to plug in 2 for all the answer choices to see which one matches the answer I got in my problem. So what that means then, there's no rhyme or reason to this. I have to just try them all. I'm looking for an answer choice of 12, or an answer of 12 if I plug in 2 for all these x's in A through E. Whatever one gives me 12 is my answer to this problem. Okay? This type of strategy and this type of problem is just forcing students to think out of the box a little bit. So, if I plug in, let's just start at A. If I put 2 in for A, this is 2 plus 4, which equals 6. Bob did not get $6 when he doubled his money. He got $12. So we're looking for 12, not 6. Answer choice A is incorrect. B, that's 2 plus 8, which is 10. That's 10 is not 12. B is not an answer choice. C, 2 times x. Well, x is 2, so this would be 2 times 2. That's 4. That doesn't work. Let's try D. 2 times 2 plus 4 equals, 2 times 2 is 4, plus 4 is 8. That doesn't work. So my answer choice has to be E. To see if it actually is, let's try it out. 2 times 2 plus 8. So 2 times 2 is 4, plus 8 is 12. So E is the only answer choice that, if using the original value that I made up right here, x equals 2, also gives me the same answer that I got when I worked the problem out with that value I made up. So E is the answer choice. All right? So that is the pick a number strategy. I'm going to do one more example within this video, then I'm going to have you pause the video and try one on your own. Okay, so moving to the next page. Now I wanted to show you one more example because the other situation that plays out with pick a number is when one variable is in relation to another variable, or if one variable's value is dependent on the other variable's value, okay? In this case, you can't give value to both of them at the same time or at the beginning. You have to give value to one of them, solve the problem you come up with for the other variable, okay? So this 31, first things first, if I was going to take this test and I read this question, if x plus 5 is 3 less than y, then x minus 2 is how much less than y? So the first clue that tells me I can pick a number or use this strategy is that that question is confusing. It has two variables. I don't know what either of them are. It's asking for how much x minus 2 is than y, and that's confusing in itself. And so I know that it might be helpful to give value to the variables, okay? Now, the second clue doesn't always work. In this case, the answers are the answers are whole numbers, not relationships or expressions, but the first clue is always the main one. Is the question confusing, and would it be helpful to give value to unknown variables? So that's what tells me I can use pick a number. Now, let's get back to what does it mean when a variable is in relation to another variable or is dependent on the other variable? All that means is like x plus 5 equals 3 less than y. If I write that out as an equation, x plus 5 is equals 3 less than means y minus 3. If you notice this thing, because of that equal sign and because one variable is on one side and the other variable, x is on one side, y is on the other, they're dependent on each other, or they're in relationship with each other, meaning that if x was a certain number, then y would be a different number, because you would solve for it. So if x was 2, you'd get y to be a specific value. If x was 5, you get y to be a different value, okay? So in this situation, you can't automatically jump and pick 2 random numbers for your variables, because they won't satisfy the relationship that exists within this equation. So when this happens, you still pick a number, but you only pick a number for one variable, all right? So in this case, I'm going to pick x. I'm going to say x is 2. You can pick y and solve for x, that's fine. But again, if I pick x is 2, then y is dependent on that 2, and it's going to be a specific number. If I pick y for a variable, then x would be dependent on that number, okay? So if I pick x is 2, then I work it back into the problem that I just created, this form, or this equation. I'm going to say x is 2, okay? So now I get 2 plus, 2 plus 5 equals y minus 3. And I'm going to solve for y to get my other value. So I'm going to add 3 to both sides. Oh, before I do that, 2 plus 5 is 7, okay? 7 equals y minus 3. Now I add 3 to both sides. 7 plus 3 is 10. So that gives me my y value. If I ever say that x is 2, then y will be 10. All right, it was dependent on that value of 2. So I have come up with both of my variables now. Now I can use both of these variables to answer the actual question that is asking. So the question of x minus 2 is how much less than y? Again, confusing, but now I can help myself out because I have values that make sense within the problem, and I can plug them in to solve that. X minus 2 is how much less than y? Well, I said that x is 2. So in this case, 2 minus 2 is 0. So 0 is how much less than y? Well, I said y is 10. So 0 is 10 less than 10. So my answer choice is E. E is 10. So because I picked a number for x, and I worked that into the problem and found y because they were in relationship to each other because of this equal sign, and they equaled each other, technically they were in relationship to each other, that's why I couldn't give value to both right away. Because I found x to be 2, or I made that up, I also found y to be 10 based off of that. Then I answered the question by plugging the variables back in there. So the answer choice was E, 10. 0 is 10 less than 10, which was my y. Now, with all that being said, if that is confusing, please raise your hand and I will come over and talk it through with you again. Okay, because I understand this strategy can be a little bit confusing at first before you practice it. But I would like you to look at 26. And same thing, how many hours are there in D days and H hours? The question is confusing. It has 2 variables that don't have value that need value. So I'm going to put a D equals and an H equals. Now, in this case, they are not in relationship to each other. They aren't in an equation and one doesn't equal the other. So you can give value to both of them right away. So if you make up values for D and H, try to rework it into the problem and then try to put the values you create into an answer choice to see which one matches the answer you get from the problem. Go ahead and pause it and try that. At this point you should have paused the video. I created values, I'm going to say that there are going to be 2 days and 4 hours. So if I rework that back into the problem, if there's 2 days, and we're looking for total hours, right? So if there's 2 days, I know I have to multiply that by 24 to get 48 hours. And then I have 4 hours here. So the total hours in my made up numbers of 2 and 4 is 52 hours. Going through the answer choices, if I plug in my H and my D, my 2 and my 4, I get G as the answer choice. G is the only one that gives me 52 when I do that math. 4 plus 24 times 2 is indeed 52. Please raise your hand if you didn't get G for an answer choice, and I'll come by and check your work.